Hello everyone and welcome back to the Statistics video lecture series. Today we are going to be starting a process called hypothesis testing, which is really the reason that we do inferential statistics. So a hypothesis test is the process of using a sample statistic to test a claim or hypothesis about the value of a population parameter. So for example, let's say that a car manufacturer claims that a specific line of cars gets a certain gas mileage. And what you can do is you can take a sample of those cars and take a sample mean gas mileage and then use that to test the manufacturer's claim. So when you start a hypothesis, you always need to assume that the hypothesis is correct unless it's proven false otherwise. So you would assume that the car gets that certain gas mileage until you can prove it false. So a statistical hypothesis is any statement about a population parameter. For example, this line of trucks gets more than 28 miles per gallon. That is called a statistical hypothesis. Now, when you are testing a hypothesis, you are always going to start off with a pair of hypotheses. One hypothesis is going to represent the claim itself, the mean is greater than 28, and the other is going to be its complement or its exact opposite. So the reason why we always do hypothesis tests with a pair of opposite hypotheses is because if one of the hypotheses is false, then the other one must be true, and vice versa. So the two hypotheses are called the null hypothesis and the alternate hypothesis. And either the null hypothesis or the alternate hypothesis can represent the claim that is being tested. So the null hypothesis, which is abbreviated as H naught, that is how you read this is read as H naught, is a statistical hypothesis that includes some sort of statement of equality. So null hypotheses will either contain the symbols less than or equal to, or greater than or equal to. The null hypothesis always contains a statement of equality. The alternate hypothesis is its exact opposite. The alternate hypothesis is labeled as HA. And this is the complement or opposite of the null hypothesis. And the alternate hypothesis always contains a statement of strict inequality. So the alternate hypothesis will always involve the symbols greater than, not equal to, or less than. So the alternate hypothesis always contains inequality, whereas the null hypothesis always contains equality. So when you're writing the null and the alternate hypotheses, remember these are always going to go in pairs. Each hypothesis test is going to have both a null hypothesis and an alternate hypothesis, and the two of them are exact opposites. So when you're writing your two hypotheses, one of them is going to represent the claim. So the first thing that you should do is translate the original claim into a statement such as, involving one of these inequality symbols. It's either going to be an equation or an inequality. So first, translate the original claim into math. Then you are going to write its complement or its opposite. So for example, if the population parameter being tested is population mean mu, and it is related to some value k, here are three different pairs of hypotheses that you can have to represent the relationship between mu and k. So for example, if your null hypothesis is mu is less than or equal to k, then the opposite of less than or equal to is greater than. So the alternate hypothesis would be mu is greater than k. If your null hypothesis is mu is greater than or equal to k, then the opposite of greater than or equal to k is less than. So the alternate hypothesis would be mu is less than k. And then if your null hypothesis is mu is equal to k, the opposite of equals is not equals, so the alternate hypothesis would be mu is not equal to k. So then, remember, when you're writing your hypotheses, the null hypothesis always needs to contain some sort of statement of equality. So here are just some really common phrases and how they translate into math. This is not a complete list, but this is just some of the key words to look for. So here are a bunch of ways to say greater than or equal to. We either can say greater than or equal to. At least, remember, is another really common mathematical way of saying greater than or equal to. And remember, the opposite of greater than or equal to is less than. So other alternatives for the words less than are below or fewer than, something like that. Now here are a bunch of statements that mean less than or equal to. You can either come out and say less than or equal to. At most is another really common way of saying less than or equal to. The opposite of less than or equal to is greater than, and alternative phrases to greater than are above or more than. And then some phrases that translate to equals are, is. Is a really common phrase for the equal sign, so is K or exactly K. The opposite of equals is not equal, so you can say different than or not would all mean not equal to. So what we're going to do for each of these is we are going to take this claim, translate it into math, and then we are going to write its opposite and identify which one is the null hypothesis and which one is the alternate hypothesis. Remember, when you are writing your hypotheses, you're always going to have a pair of hypotheses. Please label which one is the claim. So for the first one, a school publicizes that the proportion of its students who are involved in at least one curricular activity is 61%. So this is testing the population proportion. The symbol for population proportion is P. And they are claiming that the proportion is 61% or 0.61 as a decimal. Is translated into math, when it's just by itself, is the equal sign. So that claim translated into math is P equals 0.61. Now the opposite of equals is not equals. So the opposite of this claim would be P is not equal to 0.61. Now the hypothesis that contains the statement of equality, that is the null hypothesis, H naught. So I'm going to label this as H naught. The hypothesis that contains inequality is the alternate hypothesis, so HA is P is not equal to 0.61. Remember, in this case, your claim was the null hypothesis. It's not always going to be, so make sure that you label which one is your claim. So then for, excuse me, for the second one, let's say a car dealership announces that the mean time for an oil change is less than 15 minutes. So this is the mean time for a population of all cars that is testing the population parameter mu, and they are saying that the mean time is less than 15 minutes. So that translated into math is mu is less than 18, and I'm just going to label that as my claim. Now this is a statement of strict inequality. A statement of strict inequality is the alternate hypothesis. The null hypothesis, H naught, is going to contain a statement of equality. So the opposite of less than is greater than or equal to. So the opposite of mu is less than 15 is mu is greater than or equal to 15. So in this case, in number 2, the claim was actually the alternate hypothesis. Whether your claim is the null hypothesis or the alternate hypothesis depends entirely on how it's worded. That first one was is 61%, so since the claim's wording contained an equality, the claim was the null hypothesis. For number 2, the mean time was just less than 15 minutes. Not 15 minutes or less. 15 minutes or less would be less than or equal to 15. This was just less than 15 minutes, so that is a strict inequality, a strict less than, so the claim was actually the alternate hypothesis. So pay attention to how your claim is worded, and that will determine whether it is the null hypothesis or the alternate hypothesis. So then for number 3, a company advertises that the mean life of its furnaces is more than 18 years. So I'm going to first translate that sentence into math. Population mean is mu, is more than 18 years. Not 18 years or more, just more than 18 years. So just more than 18 years is going to be mu is greater than 18. If it were 18 years or more, this would be greater than or equal to. But because it's just more than 18 years, it's just mu is greater than 18, and I'm going to label that as my claim. Now, since this is a statement of strict inequality, this is the alternate hypothesis. So in the case of number 3, our claim was the alternate hypothesis. Its opposite is going to be the null hypothesis, which always contains a statement of equality. So the opposite of greater than is less than or equal to. So the null hypothesis will be mu is less than or equal to 18. Now, as you just saw, your claim could either be the null hypothesis or the alternate hypothesis. And no matter which hypothesis actually represents your claim, you are always going to start a hypothesis test by assuming that the null hypothesis H0 is true. And after performing the test, you're going to get one of two outcomes, and these are the only two outcomes. You are either going to reject the null hypothesis, or you are going to fail to reject the null hypothesis. Those are the only two decisions that you could possibly make. You're either going to reject the null hypothesis or you are going to fail to reject the null hypothesis. Notice how neither one of those was proving the null hypothesis true. It's either going to reject the null hypothesis as false or failing to reject the null hypothesis. So your two outcomes are either reject the null hypothesis or fail to reject the null hypothesis, never proving the null hypothesis true. Now remember that these conclusions are always based on a sample. So there is always a possibility that no matter how careful you are, you could make a wrong decision. And that's just the nature of these tests. It's just how it is. So in a hypothesis test, it is always possible that you had an unusual sample that doesn't really represent the population that well, and you can make an error in your hypothesis test. The only way to ensure that H0 is either rejected or failed to reject properly is to test the entire population, which isn't really realistic. So we have two types of errors that can occur in hypothesis tests. A type 1 error occurs if the null hypothesis is rejected when it is actually true. A type 2 error occurs if the null hypothesis is not rejected when it is in reality false. Now, you reject the null hypothesis if your sample statistic obtained from a sampling distribution is considered unusual. So you can decrease the probability of rejecting a true null hypothesis, which is a type 1 error, by lowering what is called the level of significance. The level of significance is your maximum allowable probability of making a type 1 error. So the level of significance is the probability of rejecting a null hypothesis when it is actually in reality true. Now, the level of significance is going to be some sort of small probability represented as the letter alpha, which is the lowercase Greek letter alpha. Now, you're going to set your level of significance to some sort of small value. So by setting the level of significance to a small value, you are saying that you want the probability of rejecting a true null hypothesis to be really small. These are the three most common levels of significance. We can have an alpha of 0.10, which is a 10% chance of making a type 1 error. Alpha equals 0.05, which is a 5% chance of making a type 1 error. And alpha equals 0.01, or a 1% chance. Now, once you establish your null hypothesis and your alternate hypothesis, and you specify a level of significance, then what happens is you take a random sample from the population, you calculate the appropriate sample statistic, and then you compare it to the parameter in the null hypothesis. Now, this sample statistic is what is called the test statistic. So the test statistic is just simply the sample statistic that is used to test the claim about the population parameter. Now, if you assume that H0 is true, you can convert your test statistic into a standardized test statistic. These are things like z-scores, t-scores, and these standardized test statistics are used in actually making the decision about the null hypothesis. So one way, there's actually going to be a couple of ways that you can decide whether to reject or fail to reject the null hypothesis. Here's one of them. One way that you can decide to reject H0 is to determine if the probability of obtaining your standardized test statistic is less than the level of significance. So here are the test statistics that we are going to use. We are going to start by testing claims about the population parameter mu. So we will start by testing claims about the population mean. So the test statistic that is used to test claims about the population mean is the sample mean, x bar. And which standardized test statistic you turn it into depends on whether or not you know sigma. Sounds familiar? If you know sigma, you're going to turn your x bar into a z-score. If you do not know sigma, you are going to turn your x bar into a t-score. Then after that, we are going to be testing claims about the population proportion p. So the test statistic for the population proportion p is the sample proportion p hat. And the standardized test statistic that we will turn this into is a z-score. So that is what is going to be coming in the rest of this chapter. So here's the actual definition of a p-value. If the null hypothesis is true, then a p-value is the probability of obtaining a sample statistic with a value either as extreme or extreme than the one determined in the sample data. And what exactly your p-value is depends on what type of test you have. And there are actually 3 different types of hypothesis tests. You have a left tail test, a right tail test, and a two-tail test. And what type of test you have actually depends on the claims that you have, both the null hypothesis and the alternate hypothesis. So let's say that your alternate hypothesis, HA, contains a less than symbol. If your alternate hypothesis, HA, contains a less than symbol, you have a left tail test. And if you have a left tail test, that means your p-value is going to be the area to the left of your standardized test statistic, whether that's a z-score or a t-score. So P will be the area to the left if you have a left tail test, and you have a left tail test if your alternate hypothesis contains a less than symbol. If your alternate hypothesis contains a greater than symbol, then you have a right tail test. So if your alternate hypothesis contains a greater than symbol, you have a right tail test, which means that your p-value is the area to the right of the standardized test statistic. So right tail test would be HA contains a greater than, and P is going to be the area to the right of your standardized test stat. If the alternate hypothesis contains a not equal to symbol, then you have a two-tail test. And by its name, this one is going to contain 2 tails. So in a two-tail test, you're actually going to get 2 standardized test statistics that are going to be symmetric, one on the left and one on the right. P is the area of both of these tails put together. So P is the area of both of those tails combined, which means that each individual tail is 1/2 P. So 1/2 of your p-value will be the area to the left of this negative standardized test stat, and the other half of your p-value will be the area to the right of this positive standardized test stat. So if your alternate hypothesis contains a not equal to symbol, you have a two-tailed test, which means the P is the area both to the left of this standardized test stat plus the area to the right of this standardized test stat. So we're going to take those same three pairs of claims that we just translated into math and found the null and alternate hypothesis. We are going to determine whether the hypothesis is left-tailed, right-tailed, or two-tailed, and then we're going to sketch the normal sampling distribution and shade the area of the p-value. So for that first one, the school publicized that the proportion of students who are involved in an extracurricular activity is 61%. So we already found the null and the alternate hypothesis for this first one. The null hypothesis was P is equal to 0.61, and the alternate hypothesis was P is not equal to 0.61. The type of test depends on what symbol is in your alternate hypothesis. So since the alternate hypothesis contains a not equal to symbol, this is a two-tailed test. Since the test is two-tailed, that means in your normal sampling distribution, you're going to get two test statistics, and P is going to be both the area to the left of that negative standardized test stat and the area to the right of that positive standardized test stat. So P will be the area of both of them put together, which means individually each tail is 1/2 of your p-value. So this left tail is 1/2 p, and this right tail is 1/2 p. So then for number 2, the car dealership announces that the mean time for an oil change is less than 15 minutes. So we already determined our null and our alternate hypothesis. The claim was mu is less than 15, and that was our alternate hypothesis, which means the null hypothesis was mu is greater than or equal to 15. The type of test depends on the symbol that is in the alternate hypothesis. So the alternate hypothesis contains a less than symbol. That means that this is a left-tailed test. Because this is a left-tailed test, that means in your normal sampling distribution, your p-value is going to be the area to the left of your standardized test stat. And then for number 3, a company advertises that the mean life of its furnaces is more than 18 years. So we already figured out that the alternate hypothesis was mu is greater than 18. And then, the null we already found was mu is less than or equal to 18. Now remember, it doesn't matter which hypothesis is your claim. I don't care if the claim is the null hypothesis or the alternate hypothesis. The type of test is always dependent on the alternate hypothesis. So since the alternate hypothesis HA contains a greater than symbol, this is a right-tailed test. Since this is a right-tailed test, that means in your normal sampling distribution, P is going to be the area to the right of your standardized test stat. Now, once you have figured out the null and the alternate hypothesis, the type of test, I'm going to walk you through in a later section how to actually find those areas and to actually find your p-value. But once you find your p-value, all you have to do is compare your p-value to your level of significance alpha, and that will determine the decision you make in a hypothesis test. So this slide is extremely important. Make sure you write this down. If your p-value is less than or equal to alpha, remember, alpha is your level of significance. So if p is less than or equal to alpha, then you are going to reject the null hypothesis H naught. If your p-value is greater than your level of significance alpha, then you are going to fail to reject the null hypothesis. So the initial decision is always made about the null hypothesis. You're either going to reject the null hypothesis or you're going to fail to reject the null hypothesis. Now, failing to reject the null hypothesis does not mean that you have accepted the null hypothesis as true. So, this is an extremely important distinction. You are never going to prove a null hypothesis true. Now is not a great time for the subtitles to glitch out. Give me a second to fix this. Okay, let's try that again. If you fail to reject the null hypothesis, that does not mean you prove the null hypothesis true. You are never going to prove the null hypothesis true. Failing to reject H0 means that there is not enough evidence to prove H0 false. So you're either going to prove H0 is false, or you're not going to have enough evidence to prove it is false. You will never prove H0 true. Now, if you do want to ever support a claim or prove a claim is true, you need to word it in such a way that it actually becomes the alternate hypothesis. Because if H0 is false, that means HA must be true. If the null hypothesis is proven false, that means the alternate hypothesis is automatically true. That's the entire reason why we have this pair of hypotheses, is because if the null hypothesis is false, that means the alternate hypothesis is automatically true. So if you want to support a claim, you need to word it in such a way that it is the alternate hypothesis, because the alternate hypothesis is the only hypothesis that we can ever prove true. Now, if you want to reject a claim, you need to word it in such a way that it is going to be the null hypothesis, because the null hypothesis is the one that we can reject. So here are the different outcomes of a hypothesis test. Let's say that the decision was made to reject H0. Now, if your claim was H0, that means there's enough evidence to reject the claim. If your claim was the alternate hypothesis, that means there is enough evidence to support the claim. So it depends. That's why you need to label which one your claim is, because your initial decision is either going to be reject or fail to reject H0. The interpretation is going to be determined by which one your claim was. If you're rejecting H0 and your claim was H0, you've just rejected your claim. If you reject H0 and your claim was HA, you have just supported your claim. So make sure that you label which hypothesis stands for your claim. Now, if the decision is made to fail to reject H0, then there is either not enough evidence to reject the claim if your claim was H0, or there is not enough evidence to support the claim if your claim was HA. Basically, if you end up with a fail to reject H0, you basically have an inconclusive test. You cannot reject H0, you don't have enough evidence, and you cannot you cannot support HA. So a fail to reject is basically an inconclusive test. Definitely make sure that you write this slide down, because these are going to be the different interpretations depending on what your decision is and what your claim is. So here are the overall steps to actually conducting a hypothesis test. What you're going to do is you're going to state the claim mathematically and identify which hypothesis it is. Remember, the null hypothesis always contains some sort of statement of equality. The alternate hypothesis always contains a statement of inequality. Every hypothesis test needs both, so once you figure out which one your claim is, you need to state its opposite to get the other hypothesis. Then, once you have H0 and HA written, you're going to specify the level of significance that is going to be alpha. Then, you're going to determine the sampling distribution and sketch its graph. It'll be a Z distribution or a T distribution. We're going to get more into that in later sections. Then, you're going to calculate the standardized test statistic. Again, we're going to cover how to do that in later sections. And you're going to add it to your sketch. And then depending on whether you have a left tail test, a right tail test, or a two-tail test, you're going to find your p-value. Your p-value is going to be either the area to the left of your standardized test statistic if you have a left tail test, the area to the right of your standardized test statistic if you have a right tail test, or the area both to the left and to the right of your two standardized test statistics if you have a two-tailed test. Once you have figured out your p-value, you're going to compare it to alpha to use and make an initial decision. If your p is less than or equal to your level of significance, that means you're going to reject H naught. If your p is greater than your level of significance, you're going to fail to reject H naught. Then, using this slide over here, you're going to then interpret your decision in the context of the problem, and remember, it does depend on whether your claim is H naught or HA. So in the next sections, we are going to be doing hypothesis test we're going to start with population mean, and then we're going to move into testing hypotheses about population proportion. So we're going to actually do a hypothesis test in another section. This section was just kind of an intro into what hypothesis tests are and the overall concept of how to do one of these tests. So thank you all very much for watching, and I will see you in the next section for when we test our first hypothesis about population mean. See you in the next one.